recientemente elegido académico correspondiente extranjero de nuestra casa. Es el primer acto en el que participa. Yo voy a pedir a uno de sus colaboradores, y no sé en qué medida alumno de nuestra casa, que haga el favor de presentarnos al conferenciante.
Bien, solo unas palabras para comentar que fue en noviembre del año pasado cuando la sección de exactas, por unanimidad, acordó nombrar a Haïm Brezis miembro extranjero de esta Real Academia de Ciencias en función de los méritos adquiridos a lo largo de una carrera ya dilatada, habiendo recibido honores como los de miembro de la Academia de Ciencias de Francia, miembro extranjero de muchas otras academias, doctor honoris causa por la Universidad de Lovaina, por la Universidad de Haifa, miembro recientemente del Instituto Universitario de Francia, colaborador sobre todo con numerosos equipos matemáticos del país, no ya solo de Madrid, sino también de universidades como la de Bilbao, Granada y otras. Su libro de análisis funcional es hoy día un libro obligado en todos los cursos que introducen a los alumnos a nivel de licenciatura a la moderna teoría de ecuaciones en derivadas parciales. En España tuvimos el honor de ser la segunda lengua en acoger al libro, incluso antes que el inglés, y hoy día este libro, ya con 4 ediciones en Francia, ha sido traducido a los lenguajes más extraños que uno se le puede ocurrir, hasta incluso coreano, si es que se dice así en castellano, que no estoy muy seguro. Hace poco un amigo historiador me decía que la historia está cargada de futuro, y yo no le entendía muy bien lo que quería decir con eso, y hasta que hace poco, preparando una jornada que se celebró en el Congreso de los Diputados, investigué un poco los correspondientes extranjeros de esta academia. En la lista de correspondientes extranjeros de esta academia hay nombres como Maxwell, como Gauss, como Cauchy, y es para nosotros un honor tener a una persona sin duda alguna de esa talla, como es Haïm Brezis. Haïm Brezis en su momento colaboró a nivel de alumno con matemáticos que hoy día son sin duda considerados como los mejores matemáticos de nuestro siglo, del estilo de Louis Nirenberg, Guido Stampacchia, Jacques Williams y otros muchos, Felix Lauder. Ya con el paso del tiempo, esa condición de colaborador, de alumno de ellos, ha pasado a ser enteramente uno más de esos matemáticos que por su producción, su enorme obra, con más de 30 tesis dirigidas, muchos de ellos del orden de 17 son ya profesores en Francia, pues consolidan una obra realmente prestigiosa. Es para esta academia un honor entonces acogerle y contar con un aliado fuera de nuestro país que defienda sus intereses. Muchas gracias.
I apologize, I will speak in English. My Spanish is more like Latin that I learned for 6 years. I'm really ashamed my Spanish is very mathematics section. Mr. Ambassador from Israel, Monsieur le conseiller pour la science et la technologie de France. I'm really greatly honored and very touched to receive this great honor for a number of reasons. The first reason is my mathematical contacts, and in fact I would like to tell you about the beginning. Professor Ildefonso Diaz mentioned very kind words for me, and very grateful. And he was at the beginning of the story of our contact, and I would like to tell you spend a few minutes about how it started. It's very glad to see here Professor Miguel Guzman, who was responsible for my first invitation to Spain in 1973. Well, for many of you, 1973 is not very long ago, but I must say it all was for scientific, the scientific level, it was like prehistory of Spain. And in fact, Spain was, well, there were great scientists, but there was such a sense of isolation. People that were not used to travel, to come to Spain. Well, there were really very few visits. And in fact, as a result, in my first visit to Spain, when I was invited by Professor Guzman, I got a splendid hotel, 4-star hotel. I was a young guy. I was more used to youth hostels, and I got a 4-star hotel. And even now, mathematicians, when they are invited, very often now they say, come with your expenses, bring your backpack and bring your sleeping bag. And there I got, really, this was the first time that one could see that people had a sense of appreciation that this was really a unique and very special event. So I'm very grateful for Miguel, for Professor Guzman, for inviting me. And on this visit, so this was my first visit to Spain, he introduced me to young, very talented young people. This was Professor Ildefonso Diaz, who was very young, but I was very young too. I don't know, we don't have so much age difference, maybe a few years. And Professor Juan Luis Vasquez. They were the two very bright young people at that time. And so we had a little bit of discussion. They took me one museum, went to the Prado, one mathematical problem. Went to Toledo, one synagogue, one mathematical problem. One church, one mathematical problem. We went like this for a few days. Oh, I forgot the flea market. How is it called? Yes, flea market, one problem. and then, so this was the first encounter. And then the second encounter, I remember it very well. This had happened in Paris. This was a few months, 6 months, maybe 6 months, a year later. I was giving a course, you remember, I was giving a course at the École Normale. École Normale is a very prestigious school in France. This is the French Harvard. And for me, I was very nervous. Maybe some of you know the story. I told the story in the book. I was trying to enter the École Normale, but I could not enter the École Normale because the examination is a long examination. It takes place every day of the week. Well, not Sunday, but it takes place Saturday. And I didn't want to take this exam because I'm a observant Jew. This was Shabbat, and I didn't want. And there was no way, and I could not enter the École Normale. I did not enter as a student. But then I became a professor at the university, and I got my vengeance. The École Normale invited me as a professor to teach there. And I was there teaching my first course at the École Normale. And in the middle of the course, in the middle of this first, I was very excited, very nervous. In the middle of this class, with all those bright students, I was concentrating on the course. In the middle of this class, someone knocks on the door. Please, could you come out? There is someone from the Ministry of Foreign Affairs who wants to talk to you. They have come especially to see you. They went to the university. They couldn't find you, so they were told to come to the École Normale. Okay, so I go out, stop the class for a few minutes, and there was some member of the Affaires étrangères, the minister, a lady from the Ministère des Affaires étrangères, Ministry of Foreign Affairs, who was accompanied by those two young people, Ildefonso and Juan Luis, right? You remember Juan Luis? No? It's not true story? Oh, you don't remember. I remember the story. I was very impressed by that. And I'm telling you the story because it was so unusual. that contacts were made through the help. We really needed the help of the people who were involved. I mean, usually they were either diplomats or so. This, I mean, today the contacts are so frequent, and so I'm sure that you never stop a class. Today you don't even you don't stop a class. But there it was really a very, just to tell you how unusual that we needed the help of diplomats for scientists to get together. And so now we are 25 years later, and I must say I'm enormously impressed by the change in Spain now. In a short time, there was around Ildefonso and Juan Luis, there was a group of young people. They stimulated, they had themselves students, and now they quickly reached a critical mass of people who were helping, talking to each other. And now I must say I'm really very pleased to see that Spain has reached maybe not the very top, but just under the very top, the group of the most active countries in mathematics. And in fact, I'm very excited. This morning, Ildefonso told me that he has solved a problem which I asked 25 years ago. So you see, this was, this is really, I'm very excited. And it's really, and he had heard this too. The contacts were not only between him and me, between Juan Luis and me. It was also, I had a whole group of students, and they became good friends with those students who are now professors all over in France, in Tours and Besançon, and they became their friends. So I had mentioned this problem of my students in Paris, who's now a professor. He never managed to solve, but he passed the problem to Ildefonso, and Ildefonso now just told me he solved it. So this morning, I must say, I really had the feeling of a family gathering, and to see all those generations of students. And the second reason that I'm very touched, very moved to be here today in Spain, in Madrid, is that I feel I'm not here alone. I'm coming with a generation of Jewish scientists, philosophers, linguists, poets, grammarians, commentators of the Bible, who were very active in Spain. And I must say, in all my visits here, especially when we went to Toledo with Ildefonso, he was always extremely proud, and I was always very touched of the Jewish activities in Toledo, this intellectual atmosphere which prevailed in Spain. And of course, I'm also standing here with the memories of the Jews who were humiliated, the ones who were massacred, the ones who were expelled in an event which was really one of the worst cataclysms in Jewish history, thinking of 1492, the expulsion of the Jews from Spain. And unfortunately, I mean, it was considered one of the worst cataclysms until 50 years ago. We realized that there is no limit to human cruelty. I don't know if my own family comes from Spain. We have no such tradition. But the family of my wife has a tradition that the family was originally in Spain. And also, I think if we believe in probability, in mathematical probability, I would like to show you one statistics which I have just discovered by serious historians about the Jewish population in the distribution of Jewish population in Europe. Here you can see Can you read this? Here you have the proportion of Jews. Those numbers, they are the proportion of Jews, for example, who lived in Spain, who lived in Italy, who lived in the Holy Roman Empire, in France, around 1300. Of course, this is a very rough estimate, and there are lots of discussions about that. And you see, in around 1300, this was, for example, 33.3%. At the time of the expulsion, 1492, there were almost 42% of the total Jewish population in Europe was living in Spain. So basically, 1/2 of the Jews from Europe were living in Spain. Now, if you are a little bit familiar with ergodic theory in mathematics, and ergodic theory, for those of you who are not mathematicians, means mixing movement and so forth of the Jews and combinations of families in the Jewish population. This means, that probability 1, almost certain every Jew who is living in Europe has either a Jewish grandfather, a Jewish grandmother who was originally from Spain. So I can consider myself, not only spiritually, as you are going to see, there were so many scientists that I consider myself a spiritual heir of the scientists who lived in Spain, but also probably just by the blood. And I know that many Spaniards, especially people from Toledo, also feel that they have connection to the Jews. And so it's not only through this family feeling that I mentioned earlier that we feel that we have close ties. Before preparing my, when I was in I gave the title, My Vision of Mathematics, and then I started preparing this lecture, and I said I should really learn more about the Jewish history in Spain. So I started to read, and so I am not a historian at all, but I read some material, and I would like to share some of my discoveries which I have made. Well, of course, let me start with one Hebrew poem by the very famous, perhaps the most famous Hebrew poet from the Middle Ages. This was Yehuda Halevi, and I will talk more about him a little later. There is a poem about Israel, about Jerusalem, which almost every child in Israel knows. Every Jew who knows a little bit of Hebrew has learned this poem, and it starts by saying, "Libi b'mizrach v'anochi b'sof ma'arav." I am my heart is in the east. That is, my heart is towards Israel, towards Jerusalem. The east is Mizrach, and it's of course where the sun rises, and it has also mystical connotation. It's always a direction where one prays the Mizrach. V'anochi b'sof ma'arav. But unfortunately, I am at the farthest point of the west. Of course, this was before Columbus, the discovery of America. So the Jews in Spain were dreaming about Jerusalem. They were dreaming about Zion, about Israel. And now that many of the Jews have been back to Israel, what are they dreaming about? They're dreaming about Spain. Let me give you two truths. First of all, it turns out, I hope I'm not going to embarrass my daughter. She goes to school in Jerusalem, and about a few months before I got this wonderful news about my election, she had to do a work which is called The Jews in Toledo. So she did a whole search, 25 pages, And so when I got the news of my election, I asked her, to borrow this work that she had done. So I'm really grateful for her help. The second proof that I would like to show you about the impact in Israel and the Jewish tradition of the memories of Spain is I would like to take you for a little walk in Jerusalem. And soon in June, some of you know that we are going to have a European meeting. We are all three countries, France, Spain, and Israel, are part of a European network. And we are going to have there in June the main meeting of the network. And so Juan Luis will be there, Javier will be there. So let me show you the map of Jerusalem. No, I mean, both of you have already been there. So, but let me show you some of this. We probably didn't pay attention to the names of the street. So here is this map of Jerusalem. Can you see this map? Okay. This is only part of Jerusalem. This is not the whole city. I've taken a zoom on the heart of Jerusalem. This is the Knesset, the parliament. Here you have the presidential residence, the Academy of Sciences. So you can think of this as the area, I mean, compared in Madrid, this would be exactly our area where we are. This is between the Cortes and the Academia Real. So this is really, I would say, the most fancy, noble part of Jerusalem. And I would like to draw your attention to the names of those streets here. Okay, let me take some of those names. And this will show you how influential how the Jews in Israel are thinking about the contribution of Spanish medieval Jewry. Let us start with this poet, this famous poet, Yehuda Halevi. And curiously, he's not there. You may wonder why he's not in this area, in this neighborhood. I suppose he's up there on the top. Can you see the various tops? There are Yehuda Halevi, very top of the map, Yehuda Halevi. I don't know why he's not with all his friends and colleagues. Probably he was so well known, so famous. All those streets are very small, small street lined with trees. Probably they thought that he needed a boulevard. And so they put him very top, very big boulevard. It's called Yehuda Halevi. Let me extract some of I've taken a number of articles in the Encyclopedia Judaica, and I would like to share with you some of the things which I've discovered there. So, of course, he was a famous poet, philosopher, and I'm really delighted that you are with us, Mr. Ambassador from Israel, to share this. And I have even some suggestions about more names.
I'll give you a suggestion. I live at Yehuda Burla Street.
Okay. But I have suggestions for other names which are missing from the map. And maybe, I don't know if you have connections with the mayor of Jerusalem to suggest a few more names there, especially about scientists. The mathematicians have been mistreated and are somehow missing from this list of streets. So you see his connection very well, birthplace in either Tudela or Toledo, connection Granada, Cordoba, this atmosphere, they mentioned the atmosphere of wealth and culture, so not only he contributed, but he also derived much of his education was from this fantastic environment. He was in contact. This was really a fantastic period. It's a dream period. Things have changed, unfortunately, today, but there were very important contact between Jews and non-Jews. He practiced medicine in Toledo, and he had also, what I would like to emphasize is the role of the Jews as contacts, and we are going to see several examples, between scientific contacts between France and even Germany and North Africa. They were really the people who brought science from one place to the other, and not only science, Jewish activities. So he had contacts with North Africa. He was really dreaming of Israel when he was in Spain. And I found some very interesting statements about him. He was a very modern personality. When he was in Spain, look at this. He thought the ideal existence for the Jews was attainable only in their own lands. And then in his philosophical work, in his poetry, he spoke harshly against those who deceived themselves by speaking of Zion and praying for its redemption when their hearts were close to it and their action far removed to it. If you see now the debate in the Jewish community about those who support Israel from far, this is really extremely modern notes. And then, but he decided finally, in his later years, to go to Israel, and it was not such an easy decision. And the Judaica, the encyclopedia, mentioned that he struggled deeply with his intimate attachment to Spain and the land of his father's grave. And at one time, he had even looked upon Spain with pride and thankfulness as a homeland for the Jews. And finally, in the end of his life, he reached Jerusalem, and legend said that he was unfortunately killed. He is very well known for his poems, Love, and the original description of feminine beauty. And here I found something amusing. The interpretation of Yehuda Halevi poems vary. Some assert that they reflect his personal experiences, while others maintain that they are simply artistic compositions. And then he also composed poems for praise of wine and pleasure. Can you imagine today a poet who would be considered at the same time a poet, religious poet, and a poet who talks about the beauty of ladies and the wine of okay. Let me skip this. We continue with some of the other names. Let's go to Alfasi. Alfasi Street is, maybe I should have the hat of one of my daughters. You want to, you have to point the streets where, maybe Rachel knows better the street? Do you know the street? You know the, well, those of you who find the street. Alfasi Street is where we live when we're in Jerusalem. And that's something interesting which I discovered while studying about Spain, is that I had always in mind, if you look at the name Alfasi, means from Fez, because in fact he was born in Algeria and then he lived in Fez. But if you continue the article, it says that he was forced to flee to Spain. He had problems in Fez, and after a few months he arrived to Cordoba, and then he moved to Lucena, and that's where he became the head of a school, a very famous school. So this is Alfasi. So I'm proud that we live in this street, which is also part of the history of Spain. And look at the words. I mean, you are going to see the encyclopedia has such an admiration for all those people. Look at the kind of words, for example, they use about Alfasi. Jewish scholars of later generation were unstinting in their admiration of Alfasi and his books, and even the famous Maimonides. In a few minutes we are going to talk about Maimonides. He talked about the great rabbi. He was the teacher, one of the teachers of Maimonides. Okay, let's continue. Now I would like to show you something that you may not have ever opened in your life. This is the first page of a Hebrew Bible with the commentary. This is the book of Genesis. And Juan Luis knows a little bit of Hebrew. Can you read? Has learned when he was visiting. No, you cannot read. Okay. So this is Breshit, Genesis. And this is not even the first verse. These are just the five first words of Genesis. Bereshit, in the beginning, God created the sky. And then, okay. This is the commentary here, and then here you have the 5 words of the Bible. All this is commentators. Let me show you more. This is not even the verse, nothing, commentaries. And then it continues. Now, by whom are the commentaries? Ramban and Ibn Ezra. Well, where's Ramban Street? There you see Ramban Street and Ibn Ezra. They are among the most famous commentators of the Bible, as you can see, which are studied today. Did you study in the school? Confirmation. And here is Ramban. Well, you may not recognize the name. Here it's under Nahmanides. Now let me explain to you this tradition, because I can explain this also. It has a connection with my name. My name is Brezis. It is a Hebrew name composed in this tradition of using the initials of the name. So, for example, Ramban was Rabbi Moshe ben Nachman, okay? The initial of his name. And his family name was, so is now used under the name Nahmanides sometimes. My name is also Brezis ben Rabbi Shalom Zeli. So same Jewish tradition over the centuries. Now look at, he lived in, he was born in Spain, he lived in Spain, and in Girona. Look at what I said about the contacts. They were really, the Jews were really the first people who had European networks like we have today, Erasmus, Tempus, and so on. He had connection with the Jews of northern France, the Jews in Provence, the Jews in southern France, the Jews of Narbonne. He was also, that's interesting, he was really, you could see he was famous rabbi, commentator of the Bible, but he was also a physician. This was a very common Jewish tradition, not to be only a religious person, but also to be a scientist or an astronomer, a physician. Okay. There is an interesting, he was connected with one interesting event, a controversy. This is something which was happening quite often in the Middle Ages. Jews were opposed to Christian sometime on the religious discussion. They had to make a religious fight and discuss the verse of the Bible, comment them. Unfortunately, you know game theory in mathematics, win, lose. This was really a lose-lose game. You know that you lose whatever happens. And this is really what happened to Nahmanides. He had a disputation in the presence of the king and with Dominicans and Franciscans, and he won. victory for Nahmanides, and he was even presented, the king presented him a large prize. As a result, he got into trouble, and eventually he had to escape and leave Spain as a punishment for his victory. And you can see the encyclopedia is really full of praise, not only for his biblical commentary. You can see his work on the halakha, means the Jewish law, one of the masterpieces of rabbinic literature. It's become a classic, and religious literary creativity, connection again with the French, the best of the French scholars. So here I would compare Nahmanides to Ildefonso and Juan Luis, because you see what they say about they adopted the mode of learning characteristic of the French, and he brought this to Spain, the French tradition, and this was a method which was not followed in Spain. And in this way, he created a new synthesis of the method of study in Spain, together with the French, bringing the French tradition to Spain. And as you can see, this threefold: Spanish, French, Provence. Provence was separated from France, was not part of the French kingdom, but was culturally very close to Spain. Okay. Ibn Ezra, we could go on, commentator of the Bible. He is also a grammarian. Where is Ibn Ezra? Yeah, you can search over Ibn Ezra. And then there are works about, I don't know here if there are any historian of mathematics. I have not started. I'm not a historian of mathematics, and there are words which puzzle me here, and which I have to understand better. That he introduced the decimal form of writing numbers using, in Hebrew you use letters, and the zero is still missing. And apparently he introduced a device for the use of zero. I must say, if it is his contribution, there could be better. There were people who were before him. I don't know if he should be really considered as a big scientist, but we are going to see that there were really excellent scientists. Okay, let's get to Maimonides. Again, Maimonides. No, Maimonides is under the name of Ben Maimon. Yeah. It's a beautiful street, by the way. If you go there, it's a really recommended street. And you are going to see, codifier, philosopher, royal physician, the most illustrious figure in Judaism in the post-Talmudic era, one of the greatest of all time. You have all heard in Spain about Maimonides. Apparently he worked on the Jewish calendar, and he has a book on logic. If anyone finds this book on logic, please let me know. There might be some maybe here at the Academy, the Royal Academy. Okay. He had contact with the French people also. His influence was enormous. I must say, personally, you are probably thinking that Maimonides is one of my favorite persons. No. I'm sorry, I'm going maybe to disappoint you. He's not my hero. And I will, I'm talking to mathematicians here, I will try to make a comparison. What Maimonides did was very similar to what Bourbaki did in France. You have all heard Bourbaki. He almost killed Bourbaki, almost killed mathematics. Because it was too good, too organized, too well... you all agree that Bourbaki, what did Bourbaki? They took a whole set of ideas which are a little bit chaotic and had no beginning, no end, no clear definition. And they made it a very well organized, fantastic text, which is beautiful to follow, to read, such a fantastic organization. Everyone is in full of, I mean, in the 50s, everyone was in great admiration of the Bourbaki style. I'm sorry, Mr. Ambassador, do you have some scientific background?
I'm getting it now.
Okay, but your scientific friends are going to tell you about Bourbaki. Bourbaki was the French school of mathematics, which was extremely formalistic. They took a number of mathematical papers which were flourishing and full of ideas, not very well organized. Sometimes the proofs were not very well. And what Maimonides did, he did exactly the same. He took the Talmud, which is a set of ideas, totally disorganized, absolutely chaotic. There are no clear decisions what you should make. It's a whole collection of opinions. And he organized it in such a way. He decided the Talmud is too chaotic, it's not useful. Let's go immediately, let's see what is the right decision that one should make in such and such case. And he was adopted because people, I mean, like in the 50s, the Jews, I must say, have not yet made this revolution that mathematicians have made. Many of the Jews are still in the period of the 50s where Bourbaki was regarded as a god. Now we are 50 years later. Bourbaki is regarded as really a catastrophe. Things were too formal. Now today, maybe the hero is Poincaré, who had a fantastic intuition. Things, Poincaré, you know the work of Poincaré, also connected to chaos and so forth. Poincaré is really perhaps the god. And I'm taking this opportunity also to talk to the representative of the French community, which is not a mathematician, and I hope you don't represent the former minister Allègre. There was maybe you heard about the controversy in France. The minister of Education, Science, made incredible attacks. That's Allègre, who is an earth scientist, a very well-known, good earth scientist, who was educated in this Bourbaki tradition, and he remained. I mean, his idea of mathematics is still that Bourbaki was the hero of the day, and because of that, he found that Bourbaki is really a terrible thing, because it's not useful in science. Things are too frozen, it's too axiomatic, and so forth. And because of that, today he thinks of mathematics as still as a Bourbaki type mathematics, and he came with really incredible attacks against mathematics. So we are all grateful that he is gone now. But still the idea that mathematics is still anchored, that this idea that mathematics is identified with Bourbaki is a very strong idea in France, and we should teach our colleagues, our scientists, that Bourbaki is now dead, and that we have passed this period of dry. And in some sense, Maimonides is a little bit like Bourbaki. So it's not. Sorry, he's not my hero. On the other hand, of course, what is wonderful is that he was at the same time philosopher, but fantastic also physician, his knowledge of science. And I have heard, I don't know if you can confirm this, but I have heard that as a physician, some physician told me that he was one of the first people who favored, how do you say, post-mortem autopsies. I don't know if there are any doctors who can confirm that, but he was very modern for his time. So maybe as a doctor, but not like Allegra as an earth scientist, but I don't take Maimonides in Jewish studies as my hero. On the other hand, what is absolutely wonderful in Spain is that Spain has been at the same time not only the place of work where Maimonides worked, and I'm sure all of you have heard Maimonides, but maybe not so many of you have heard about the mystical tradition, the one which is associated with the Kabbalah, with the Zohar, and which I would compare to Poincaré in mathematics. It's maybe a little more chaotic. It's an idea that the world is complicated, that maybe rules are not always followed, that the world is enormously complex, that we're inventing, that we are able to understand only part of the world. And also what is fantastic in this tradition, and I must say that's a tradition which was enormously developed in Spain. So it's really, I'm very impressed that Spain had this dual tradition, both the rationalist tradition and the mystical tradition. Well, when you think, I'm always reluctant to use the word mysticism because you think of mysticism as something unscientific and so forth. The Jewish tradition in mysticism was in fact very close to science, and maybe I would say even closer than Maimonides was, in that they had a vision of a complex world that, and also a sense that it is the responsibility of man to create. There is lots of creativity in this tradition of the Zohar. Man has a responsibility to create. And I must say that's part of my vision of mathematics. Unfortunately, I will not have time to go into the details. That the world, I mean, some mathematicians, some scientists, physicists are coming with the idea that the formulas of the world come from outside, that they are parachuted from the sky, and that we have to find them, that we are like discoverers of the world, that we have to discover those structures which exist in the world. The idea of this creativity in the mystical tradition says, well, man has to invent lots of things, man has to help God, puts lots of responsibility on the shoulders of man. And I must say that when I attack the problem, I have lots of contact with physicists, with economists, with engineers, and so forth. And I realize how much the world is complicated, and that the formulas are not coming from the sky. The models of the mathematical models that we're using, that we have to invent and we have to create them together in a discussion with the others. When I have discussion with physicists in the fields which I'm most interested in, fields like which are related to not earth science, but continuous mechanics, solid state physics, and so forth, you see very well that the world is not coming with such an organized formula. We, the mathematician, together with the physicists, we have to invent the laws of the world. See, time is running, and I would like to just to finish with a few names of mathematicians who are not here, but ought to be here. And I don't know, for some reason, I don't know if the people who organized those names of the streets were like Nobel. You know, Nobel has had a prejudice against mathematicians. There is no Nobel Prize in mathematics. I don't know if the people who planned those streets of Jerusalem had also prejudice against mathematicians, that they pushed them aside. So I would like to show you a few names of people who are in the Encyclopedia Judaica, are probably less known, but still made tremendous contribution to mathematics, to astronomy, which was very closely linked to mathematics. And my feeling is that they really ought to be on this map. Of course, I'm skipping. I mean, every name that you see in this area between the Knesset and the president's house, every name, maybe not as known as Maimonides, but every name there, you have about 12, 15 names of people who are very famous in the Jewish tradition for their contribution to poetry, to a commentary of the Bible, commentary of the Talmud, grammarians, and so forth. Here are some names of streets that I cannot find. Levi ben Gershon. The abbreviation, his initials are Ralbag. He is one of my heroes, and apparently he does not have a street. I don't know, Mr. Fan, do you know if some people told me, my wife and my daughter think maybe there is a street called Ralbag. I couldn't find it in the index of streets. First of all, he was a famous commentator of the Bible, and I took classes, and one of my teachers was a famous. Had made his thesis on Gersonid, on Ralbag, Levi ben Gershon, and was very excited. So I got from his teaching, I got lots of insight into his commentaries on the Bible. But apparently, look, he worked in arithmetic, geometry, trigonometry. Apparently, he's very famous. He was one of the founders of trigonometry. Well, you're going to tell me maybe the prejudice they had against him is that he was not in Spain. He lived in Provence, in Languedoc, in fact, in France. Well, I think you could. So I don't know. The prejudice against him was because he was French and they liked Spain, or because he had done mathematics. Anyway, I think he could be. I mean, after all, Languedoc and the Provence were very close to the Spanish culture. And look at what he did, series, permutation, combination, and this was in 1288, 13 through 1344, division, extraction of roots, arithmetic, geometry without axioms. That's interesting. And, but he had apparently to introduce other axioms. But I think the most famous work is on trigonometry. And also as an astronomer, apparently he invented one of the contribution was the invention of the Jacob staff. That's an instrument which is used to measure the angular separation between bodies, and this instrument was used by lots of sailors. Then there is another name, Zacuto, should definitely be on the map. French origin, French ancestor. So you see again this going back and forth, the connection. We did not invent the connection between scientists, French scientists and Spanish scientists. And then he came to Castilla. He attended the University of Salamanca. This was in 1452. And his achievements in astronomy were apparently enormous. He played an important role in the discovery, and that Columbus used in his voyages the tables that Zacuto had done in astronomy. And those tables, they saved the life of Columbus. And what is even amusing, look at that, and I'm going to conclude on that, knowing from the Zacuto table that a lunar eclipse was imminent, Columbus threatened the natives in the New World that he would deprive them of the light of the moon as well of the sun, because he had the tables to predict the eclipse. So thank you very much again for this great honor And I hope we have many, many years of contact, seeing your mathematical children, great-grandchildren, great-great-grandchildren, that our great-grandchildren have collaborations between them. So again, thank you very, very much for this great honor, which, as you could see, really touches me for many, many reasons. Thank you.
Question, let's say. I would like to ask one question because the title, of course, of the lecture was My Vision of Mathematics. Of course, it would be a very nice opportunity for all us to hear from you, your thoughts. But you are coming from topology, from functional analysis, from domains of the mathematics which are quite abstract. Let me ask you the question, what do you think about the ordinator, the computers? It would be nice to hear from you some opinion. And I think some qualified person like you may give us.
That's a very, very good question. And do you give me a few minutes to answer it? It's not a simple question, and I think it's really, I would like to take this opportunity. Thank you for giving me this opportunity. I intended to talk about this, and especially in connection with remarks which were made by the Minister Alleg about the use of computers. And the situation is that a number of people, including the Minister Alleg, think that time has arrived where we don't need mathematicians anymore, and that computers have replaced mathematicians. And if you take the book of Claude Alleg, he has a book called The Defeat of Plato, there he says explicitly, computers today are able to solve problems that 200 generations of mathematicians have been unable to solve. Okay. Now this shows how much the large public, including good scientists like Claude Alleg, how much confusion there is. And I think time has arrived, in fact, in the academy in France, because of such statements which were made by the minister. We think that time has arrived, and we would like to issue a study to explain what is the difference between a computer and a mathematician, what are the things that a mathematician can do that a computer cannot do, what are the things that a computer can do that conversely. Let me spend a few minutes to explain how is my view. Maybe several other people have different views, but at least we feel that we're going to have a committee in Paris, at the Academy in Paris. I don't know, maybe we should make this as a European effort between academies to create a group to develop, to explain to the public. Maybe the situation is similar in Spain, I don't know if it's as bad. To explain to the public, and including the scientific public, what is the situation. Now, my own view is the following, about this interface between the computer and the mathematician. In fact, it should have been in another place, not in Spain. There is a famous Jewish rabbi in Prague, maybe some of you have heard about him, who invented a human body which he called the golem, and you know that the first computer was called one of the first computers was called the golem, and Van Neumann, other people have been taking this as a name, as a model for thinking, and he was in Prague. So I should have reserved this for my lecture if I ever give a lecture in Prague, because the rabbi there was Rabbi Löw in Prague, who invented this kind of question. Let me, since you asked the question, let me tell you my vision of this interaction. The computer I find it enormously useful in several areas of mathematics and for several reasons. And in some, there are also enormous dangers which are attached to the computer. Let me start with the advantages. The computer, on the one hand, has replaced partly the experimental aspect of sciences, which was a stimulus for the mathematician. Okay. You see, I have a vision of mathematics as being really extremely close to physics, to all kinds of fields in the real world. And very often it is experiments in the real world which led to modeling to differential equations, partial differential equations, and then this was a big motivation for development in mathematics. So those experiments, they can be done today on the computer. Okay? And people have developed new fields in mathematics because the computer, like an experiment, like a physical experiment, did some computation, and on the screen one could see strange phenomena which were reported to the mathematician, and the mathematician say, it's interesting, we should really investigate that equation. And so, on the one hand, the computer replaces experiments. Okay. That's one very important direction, especially in my field, which is nonlinear partial differential equations. There is no way, it's very difficult for us as a mathematician to decide what nonlinear equation will be interesting. So if the computer tells us that he finds something interesting which is modeled by that equation, that's a good reason for us, the mathematician, to attack that equation. Okay. That's one area. One very important. A second area is that you all know that mathematicians make conjectures. And there are famous conjectures. Some people are very proud because Andrew Wiles is extremely proud because, and everyone is full of enormous admiration for him because he solved a problem that Fermat raised 350 years ago. And so you know the role of conjectures in mathematics. Now I'm very proud that Ildefonso solved the problem that I raised, the conjecture that I had. Or in fact, he gave a counterexample. That's even more interesting to a conjecture I had 25 years ago. So the oldest the conjecture is. Now today, it is possible sometimes to ask the computer not to solve for you the problem, but to make some computation which is going to test the conjecture. Okay? So the computer can tell you, perhaps, you should really, so a conjecture is a problem, you should decide whether you want a positive answer or a negative answer. And sometimes people have ideas. I believe that 90% chances this is okay, sometimes I make conjecture. Sometimes it's 50-50. I'm sorry, this time, this morning I could have shown problems, open problems where I really don't know, 50-50. And in both directions would be, the answer in both directions would be enormously interesting. In that case, the computer can help you make a computation, which is not a rigorous argument. This is not a mathematical valid argument, but it tells you in what direction you should investigate. And this has happened to me. We had some problems. We didn't know at all what direction to search. We asked computations on the computer. The computer said, search in that direction, and eventually not with the help of the computer, but because the computer gave us the idea to look in that direction, then we eventually eventually we put the thing rigor. Sometimes, but this is extremely rare, the computer, together with the man, can solve the problem. This has happened maybe only I mean, since the computer was invented only on celebrated problems 3 or 4 times. The most famous problem is the 4-color problem, whether you can color a map with 4 colors and so forth. The computer, I mean, the mathematician, I mean, this is a very complicated problem. It was there for over 100 years. And there are infinitely many cases to check. And some mathematicians who are very clever, they classified, and instead, and a computer, I mean, the problem with a computer is that a computer cannot check infinitely many cases. That's just outside of his reach. Okay? He can check 50 cases, 100 cases, 1 billion cases, but not infinitely many possibilities. Okay? Just outside of his reach. And the contribution in this case, that a mathematician was put together with a computer, and the mathematician said, well, we have infinitely many cases, but we can group them together, and instead of infinitely many, we'll make some packages. Those cases, they go in this. Those cases, they go in this package, this package, this package. And then in the end, the mathematician discovered that there are only finitely many cases, basically 50 cases. You give them to the computer, and then the computer can solve it. And so in this case, in contrast with the previous case, the computer makes, that's very interesting, a rigorous mathematical proof. Now, some mathematicians, of course, are not very happy. They say, but how are we going to check it? They argue, is this really totally reliable? Is the computer... and okay, that's, you know, like when you have a newborn baby, sometimes the brothers, the sister, they don't like this baby, they expel this baby, but eventually you accept the baby. So, I mean, mathematicians are eventually going to accept this new baby and say that the proofs that the computer gave with the help of a man, rigorous proof, are absolutely correct. Okay. Then there is a last direction where I see a fascinating effect of the computer on mathematics, is that we said the computer can help to solve problems. But very often you don't realize that the computer raises more problems than it poses. And there are really fabulous mathematical problems which the computer cannot solve itself, but which are needed to make faster computer, to decide what problems you can solve with the computer and so forth. So this is an enormous, how do you speed up computers and so forth. This is an enormous challenge for the mathematician. And so here the computer is a source of the new problem. I must say here the computer is like all the new fields which are emerging in science technology. They give rise to new challenges for the mathematician. Okay, now what are the dangers of the computers? What are the limits? I see, first of all, the main danger today is to think like Allegro, that the computer is just like, I mean, maybe not today, but maybe in 20 years or so, the computer is like a box, a black box. You put the question in one side, and the answer emerges. Any question emerges on the other side. That's the idea, that the computer can do everything. And as I showed you earlier, this is just not, this is absolutely not. This is really, as mathematicians, we are very nervous that too many people are thinking in this way. A second danger is in some fields, as we mentioned, for example, number theory, you have integer number. You are computing 1, 2, 3, and so forth. Now, this is not all which is used in mathematics, integers. I mean, people have invented fractions. Fractions still a computer could handle. But then you have numbers like pi, square root 2, and so forth, where you have infinitely many digits, and this is the kind of problems which occur, which are coming in physics. For example, in continuum mechanics, if you want to make computation on a fluid, on the flow, there it's not integer numbers which play a role. What happens there is that you have to take the mathematical problem and you have to replace it by an approximation that the computer can handle. Okay? There, when you make this approximation, you make always an error. That is, instead of, say, 3 of pi, you tell the computer, instead of using pi, I'm going to use 3.14 and so forth. You cannot tell him to make computations with all the digits up to the end. You have to stop. And then the whole area of mathematics has been, so-called numerical analysis, has been an area where you try to evaluate, but that's not something that you can ask the computer to do. You try to evaluate the error between the physical phenomenon or the partial differential equation which is associated with the physical phenomenon and the result of the that the computer is going to give you. Okay? So there is an error, and once you have decided and once you know how to compute this error, to evaluate this error, you can tell the computer, I want to make an error, I'm willing to make an error, but I want it to be less than 100% or so forth. And then you can tell the computer, and the computer runs the computation, and it comes with an answer, and you are sure, if you have done some mathematical work before, you are sure that the difference between the answer given by the computer and the real-world answer will be, the error will be less than 100, 10 to the minus 6, and so forth. But there you need the help of a mathematician, and lots of people, even, I mean, that's an area which is called scientific computing and so forth, forget that step, and they immediately jump to the step of giving the problem to the computer. And of course, sometimes it works. I mean, that's like, that's like the alchemist in the medieval time, the scientists we were talking about before, the chemists. Sometimes, I mean, they had a good intuition, they had some knowledge, sometimes it works. I mean, sometimes the alchemists were right, but sometimes, of course, they were totally, this brings us back to this medieval time, sometimes they were totally wrong. And in some sense, what is happening today is that some of the people who are doing this kind of computation without checking first the logical and the mathematical ground, I compare them to the alchemists.
We thanks again
for it.
Now the president of the academy will.
Before ending this ceremony, I'm very pleased as the president of the institution and on behalf of the Royal Academy to give you the greatest honor of this institution. The nomination is the foreign academician member. It's our diploma. I am very friend of Mr. Allegre, you know.
Esto lo codificaba. Uy, yo juraría que no me daba la vuelta al brazo.
Oye, te veo que te voy a saludar. Espero que se haya grabado.
Gaudeamus igitur, juvenes dum sumus. Gaudeamus igitur, juvenes dum sumus. Post jucundam juventutem, post molestam senectutem, nos habebitumus, nos habebitumus. Ubi sunt qui ante nos, immundo fuere, ubi sum qui ante nos, immundo fuere, adeassa inferos, transeassa superos, possivis videre, possivis videre. Vivat academia, vivat professores, vivat academia, vivat professores, vivat membrum quod libet, vivat membra quae libet, semper si implore, semper si implore. Gaudeamus igitur, juvenes dum sumus, gaudeamus igitur, juvenes dum sumus, post jucundam juventutem, post molestam senectutem, nos habebitumus, nos habebitumus, ubi sum qui ante nos, immundo fuere, ubi sum qui ante nos, immundo fuere, adeassa inferos, transeassa superos, possivis videre, possivis videre. Vivat academia, vivat professores, vivat academia, vivat professores, vivat membrum quod libet, vivat membra quae libet, semper si implore,